Welcome to another video, and today we solve this integral between 1 to infinity of arctangents of x times natural log of x divided by x squared. And we know the formula of arctangents of x is arctangents of x plus arctangents of 1 by x is pi by 2, where x is greater than 0. But first I want to tell you something that happened before one year left in 7 October. Hamas terrorists entered to Israel, and they killed and raped and they burned many houses and children and people in Israel. They conquer many from Israel cities, and today we are in war against Hamas terrorists in Gaza, and you know what are going to do in Gaza. The war never stopped in Gaza. Never stop. In Gaza, they have 101 hostage in his tunnel, and we pray for their return. And okay, so let's talking about math now. Okay, so let's solve this integral. So what we can do, let's believe in yourself and believe in algebra, and don't forget the 7 October. Yes, let's go. So now let's solve this integral. We know that arctangent x is pi by 2 minus that. Okay, so integral between 0 to infinity, 1 to infinity, pi by 2 times natural log of x minus arctangent y by x times natural log of x divided by x squared. Okay, dx. So this integral is equal to integral between 0 to 1 to infinity of pi by 2 times natural log of x by x squared dx minus integral between 1 to infinity of natural log of x times that, yes, 1 by x tangent 1 by x divided by x squared dx. Okay, the solution of that integral we know because this integral by parts. Okay, so let's put this integral by I0. Okay, so and this integral by I1. Okay, so the integral of that is I0 is equal to minus integral between 1 to infinity of natural log of x arctangent 1 by x divided by x squared dx. Now let's put 1 by x is d. Okay, so because the derivative of 1 by x is 1 by x squared times minus 1 dx is dt. Okay, because this is dt. Yes, so the integral between if we put 1 here, so we got 1. If we put infinity here, we got 0. But this minus will replace the bonds. Okay, so here is the plus, and integral between 0 to 1 of this natural log of 1 by t. Okay, so this is minus natural log of t times that arctangent of t, and times this minus, so now this plus. Okay, so 1 by x squared, this is dt. Okay, so cool. This is this is our integral now. Okay, so now let's do something about it. Integration by part, yes. Okay, so in this side we got we put natural log of t, and this side arctangents of t, yes. So the integral of that is t times arctangents of t, and what? Minus 1 divided by 2 times natural log of 1 plus t squared, yes. Okay, so the derivative of that 1 by t. Okay, so I0 is equal to this times that, yes. Natural log of t times arctangents of t, yes, minus that, yes, minus natural log of t times natural log of t squared plus 1 divided by 2 between 0 to 1, and this minus here, minus what? Okay, this times that. Okay, so integral between 0 to 1 of 1 by t times that is just arctangents of t, because this and that will cancel out. So dt, yes, and minus and minus, that minus and that minus will natural log of 1 plus t squared divided by t. Okay, so now what we gonna do by this, okay, let's solve this integral first, because we know that the integral of arctangents of t is t times arctangents of t minus natural log of 1 plus t squared divided by 2, yes, between 0 to 1. If you put 0 here, this is 0. If you put 0 here, this is 0. So this will come out 0. If you put 1 here, this is pi by 2, pi by 4. And minus, if you put 1 here, so natural log of 2 minus natural log of 2 divided by 2. Yes, minus 0. So this is the answer of that. Yeah, so let's see what we can do. What we can do here. If we put 0 here, so we got 0 because this greater to 0 faster. Okay, so minus natural log of 0 times that. So the limit of that when t is equal to 0 is 0, yes, because natural log of 1 is 0 times that, and the limit is 0. Okay, so if we put 1 here, so this is 0 and that is 0, so all of this is 0. Okay, cool. So I0 is that, and this the answer of that is that. Okay, so minus pi by 4 minus natural log of 2 divided by 2. Yes, okay, cool. So now that, okay, so if you put this integral by I of a, okay, so okay, we got this integral. So we know from Taylor series that the series for natural log of 1 plus x is the sum of between from n is equal to 0 to infinity of minus 1 in power n minus 1 divided by n times x in power n. Okay, so if we put x is equal to t squared, we got that. Okay, so let's write that integral between 0 to 1 times sum of from n is equal to not 0, this one, sorry, this one, to infinity of minus 1 in n plus 1 power divided by n times x t squared t power 2 times n. So t power 2n t and divided by t, so 2n minus 1. We can replace that because we know the series. If we put in n infinity and t1, this the function will be constant, so we can replace that. Okay, so 1 by 2 sum from n equal to 1 to infinity and integral between 0 to 1 minus 1 and n minus 1 divided by n, and times t to 2n minus 1 dt. Okay, so the integral is that. Okay, and the integral of that is 2 power 2n, t in power 2n divided by 2n. Yes, and let's put 0 in 1. If we put 0 is 0, if we put 1 is 1 by 2n. Yes, so we know the integral, and now let's solve for the sum. Okay, 1l times the sum of from n is equal to 1 to infinity of minus 1 and n minus 1 power divided by 2n squared, but let's void 2 here, and 2 times 2 is 4, and n squared here. Okay, let's see what we got here. Okay, let's see what we got here. This is the Euler, thin like Euler. Okay, because if we put the terms, this will be 1/4 power 1 by 4 times if we put 1 here, so 1. If we put 2 with this one, and minus 1 by 4 plus 1 by 9 minus 1 by 16 and health. Okay, so this is what this equal to. If we add 1 by 4 and minus 1 by 4, if we add 1 by 16 and minus 1 by 16, we get 1 by 4 times 1 plus that 1 plus 1 4 by 4 plus 1 by 9 plus 1 by 16 and minus 1 by 4, and this minus 1 by 4 is minus 2 by 4 minus 2 by 16 minus 2 by the next this was 4 to power, this 2 to power, 4 to power, and then 6 into power, so 36. And okay, so if we move to here to 2 factor, so this will be 1 by 4. This is Euler Basel problem. Okay, so pi squared by 6. Yes, so if we move 2 here, 2 times 1 by 4 minus 1 by 16 minus that, and let's see what this we got here. Okay, yes, if we use 1 by 4 in a factor, so let's move it 1 by 4 here, 2 by 4 here, so here we got 1 plus 1 4 plus 1 by 9, yes. So we know that, and this equal to what we need to solve that, okay? So this is another pi squared by 6, yes, okay. So this is 1 by 2, so this is equal to pi squared by 24, and if this is 1 by 2, so this will be pi squared by 12 and times 1 by 4. This is minus pi squared by 48. Okay, so now let's see what we can do. So this is equal to pi squared by 48, okay? Okay, so this is what we got, because I will show you. This integral is that, and this integral is that minus that. That we know. This part I wrote here, okay? Yes, okay, here. So we move on in this integral I0. Okay, this integral, this minus because this minus, yes. Okay, so this integral is that because we put 1 by x is d and the bonds changed. Okay, so this integral, we use the integration by part, yes, and we got this I0 is equal to that, this equal to 0, so this is 0, and minus that, okay, the integral of that is that, and if we put 1, we got pi by 4 minus ln 2 by 2. If we put 0, this 0, and that is natural log of 1 is 0, so this is 0, so this minus that is, and this minus, okay, is this part, yes, okay, and now this no, okay, and now we try to solve this part, and from here we solved that this integral is equal to pi squared by 48, okay, so plus pi squared by 48. So what is this integral? It's easy integral because let's do integration by part. Here natural log of x, here 1 by x squared, this 1 by x, this 1 by x2, but with minus, okay, so all of this equal to this times that minus ln natural log of x by x between 0 to infinity, 1 to infinity, and here we got minus, so this plus the integral of 1 by x squared. The integral of 1 by x squared is minus 1 by x, okay, so between 0 1 to infinity, and plus minus that plus that. Let's see what we can do. So if we use pi squared by plus pi squared by 48 minus that pi by 4 and plus natural log of 2 by 2, yes, so let's multiply by 12 because 4 times 10 over 12 is 48. And now let's solve this bonds. If we put infinity, this 0 because 6 go to infinity faster than natural log. If we put 1, so natural log of 1 is 0, so this all 0. Let's see what we got here. If we put infinity is 0, because 1 by 0 infinity is 0. If we put 1 is 1 by 1 is 1. So 0 minus 1 is 0 minus this minus 1, sorry. 0 minus minus 1, 0 minus of minus 1 is plus 1. So we can work that the integral from 1 to infinity of arctangents of x times natural log of x divided by x dx. Let's write this pi squared minus 12 pi. Let's multiply that by 24, because 24 times 2 is that 48, plus 24 pi divided by 48 plus natural log of 2 divided by 2, and that is